Hello friends and welcome to this video in which we are going to quickly revise some basic mathematic topics which may come handy in programming. So let's get started. First is to find number of digits in a number. So let's say that you have a number 1, 2, 3. So you need the output as 3. Since we have 3 digits 1, 2 and 3. A simple iterative solution will be to store the number in a variable n and keep dividing it by 10 till it becomes 0. So we have the count variable which stores our answer. Let's say that n is equal to 123. Since n is not 0, we enter the while loop and set n to n by 10. So n will become 12. After that we increment count. So count will become 1. Since n is not 0, we continue with the while loop and now n will become n by 10. Then we increment count. So count will become 2. Again, as n is not 0, we continue with the while loop and now n will become 1 by 10, that is 0. We increment count, so count will become 3. Now as n is 0, we break out of the while loop and return count. So we return 3. Next, let us look at the recursive solution. Coming to the recursive solution, we have this base condition that if n is 0, we return 0. And we need to maintain a stack for each function call. Taking the same number 123, since it is not 0, we go to the return part and call 1 plus count digit 123 by 10. So n will then become 12. Similarly, the next two recursive calls will look something like this. After the third recursive call, we will have n as 0 and the base condition will be satisfied. So 0 will be returned to this call. Then 1 plus 0, that is 1, is returned to this call. Then 1 plus 1, which is 2, is returned to this call. And finally, we return 1 plus 2, that is equal to 3, to the calling function, and that is exactly our output. Now, most of you might already be familiar with the iterative and recursive solutions. However, there is another one-liner solution, which is the logarithmic solution. We can use log base 10 to count the number of digits of positive numbers. The digit count of n will be equal to upper bound of log n base 10. So log of 123 is around 2.08 and adding 1 to it, it will become 3.08. Finally, we take floor of 3.08 and get 3 as our answer. Coming to arithmetic, and let me first discuss arithmetic progressions. So let's say that you have some numbers 2, 4, 6, 8, 10 and so on. In this sequence, 2 is the first term. We can denote the first term by A. The common difference, as we can see, is 2 between two consecutive terms. D is the common difference. So we can write the second term as A plus D. Similarly, the third term can be written as A plus 2D. And the nth term can be written as A plus n minus 1 into D. Now, coming to the sum of terms, we can think it in terms of average. average of n terms is given by sum of those terms divided by the number of terms. So sum will become average into n. Now average for evenly spaced numbers is given by sum of first term plus last term divided by 2. So we have first term as a and last term is a plus n minus 1 into d. Taking the 2 outside, we have n by 2 here. So the sum is given by n by 2 into 2a plus n minus 1 into d. Coming to geometric progressions, let's say that you have the numbers 2, 4, 8, 16, 32 and so on. Now the ratio of two consecutive terms here is 2. Let's denote it by r. So the second term is given by a into r. The third term can be a into r square and so on. Similarly, the nth term can be written as a into r to the power left side must come out to be 0. Then alpha will be a root to this equation. If we have a quadratic equation, we can have maximum 2 roots. Now all this depends upon a factor which we call as discriminant, and it is denoted by b square minus 4 into a into c. And the formula for finding the roots is minus b plus or minus under root b square minus 4ac divided by 2a. Now if d is less than 0, we have imaginary roots. If d is 0, we have two equal roots, and if d is greater than 0, we have two distinct roots. Coming to the programming portion, taking input from user to represent a quadratic equation means getting a, b and c from the user. Next are mean and median. The mean is found by adding up all the given data and dividing the number of data entries. For example, the mean of 4, 1 and 7 will be 4 plus 1 plus 7 by 3, that is 12 by 3, which is equal to 4. Median is the middle number, which is found by ordering all data points and picking out the one in the middle. Or if we have two middle numbers, then we take the mean of those two numbers. For example, the median of 4, 1 and 7 is 4 because when the numbers are put in order 1, 4, 7, the number 4 is in the middle. Coming to prime numbers. A prime number is a number which is only divisible by 1. A prime number is a number which is only divisible by 1 and itself. First few prime numbers are 2, 3, 5, 7, 11. Let me share some interesting facts about prime numbers. Every prime number can be represented in form of 6n plus 1 or 6n minus 1 except 2 and 3, where n is a natural number. For example, 5, which is a prime number, can be represented as 6 into 1 minus 1. 2 and 3 are the only two consecutive natural numbers which are prime too. Before moving on to LCM and HCF, let us quickly recollect factors and multiples of a number. All the numbers that divide a number completely, that is, without leaving any remainder, are called factors of that number. For example, 24 is completely divisible by 1, 2, 3, 4, 6, 8, 12 and 24. So each of these number is a factor of 24. And 24 is called a multiple of each of these numbers. The least common multiple or LCM of two or more numbers is the smallest number other than 0 that's a multiple of each number. For example, if we have to find the LCM of 4 and 6, we can write the multiples of 4 and 6 and figure out the common multiples, which are 12 and 24. The least common multiple will be 12. Moving on to HCF. HCF, or highest common factor of two or more numbers, is given by the highest number which exactly divides all the number. Let's try and find HCF of 12 and 16. Factors of 12 are 1, 2, 3, 4, 6 and 12, and factors of 16 are 1, 2, 4, 8 and 16. The common factors will be 1, 2 and 4. Out of the common factors, the highest common factor is 4, and that is the HCF of 12 and 16. Moving on to factorials. Factorial of a positive integer n is the product of all positive integers less than or equal to n. Let's say that you need to find factorial of 5. So it will be 5 into 4 into 3 into 2 into 1. That is equal to 120. So factorial of a number will be n into n minus 1 into n minus 2 up to 1. 0 factorial is interesting. It is commonly agreed that 0 factorial is 1. Let's see permutation and combination now. Permutation is defined as arrangement of r things that can be done out of total n things. This is denoted by NPR, which is equal to n factorial divided by n minus r factorial. Combination is defined as selection of r things that can be done out of total n things. This is denoted by NCR, which is equal to n factorial divided by r factorial into n minus r factorial. Moving on to modular arithmetic. In most of the programming competitions, problems are required to answer the result in 10 to the power 9 plus 7 modulo. The reason of taking this mod is to prevent integer overflows. The remainder obtained after the division operation on two operands is known as modulo operation. Operator for doing modulus operation is the percentage symbol. For example, if a mod of b is equal to c, which means that when a is divided by b, it gives the remainder c. So let's say that you want to find 7 mod of 2. So 7 mod of 2 will be 1 as the remainder is 1. The reason of taking mod is to prevent integer overflows. The largest integer data type in C or C++ is unsigned long int, which is of 64-bit and can handle integers from 0 to 2 to the power 64 minus 1. But in some problems where growth of the output is very high, this high range of unsigned long may be insufficient. That is where you can use modular arithmetic. That's all for this video. Thank you for watching.